Hello everyone, in this video I will walk you through a custom-built Streamlit app called RootFinder. This app helps solve equations using several numerical methods. Let's begin coding and understand each part step by step. First, I import the essential libraries. Streamlit is used for the user interface, NumPy helps with numerical and calculations, and SymPy is used for mathematical expressions symbolically differentiate them and convert them into numerical functions. Next, I import the UI function for each numerical method from their respective files. This contains logic and visuals specific to each method. This line sets the Streamlit page title and makes the layout wide so the interface can accommodate graphs and tables comfortably. Here, I use Streamlit's session state to manage navigation between pages. If the page key doesn't exist yet, I initialize it to show the welcome screen first. This function displays the welcome page. First, we give it a title. If I use Markdown to add instructions so the user understands what the app does and how to proceed. And finally, there's a button to go to input page. When clicked, the page state is changed. Next is the input page where user define their function and method settings. Here, we get the equation input from the user. A default polynomial is provided. I divide the next part into two columns, one for the start of the interval and one for the end. The user can now enter the range where they expect to find the roots. Here, I create a drop-down to select one or more numerical methods. And again, I use two columns, this time for the run and back buttons. And here, when the run button is clicked, I store all inputs values in session state and switch to the result page. The back button takes this user to the welcome page if needed, while this function displays the results after computations. And this line, I retrieve all previously stored inputs. With this, I convert the string input to the symbolic expression, then turn it into a callable function f and also compute derivative df for methods like Newton-Raphson's. And for this, if there's an error in a function input, this section displays it and allows users to return and fix it. I bundle the interval as a tuple to pass the methods. This dictionary maps methods name to their corresponding UI function calls. This line, terms are created dynamically based on the user selecting methods. For this, I loop through each selected method and create a subsection inside this tab. Each method is called here, returning its computed roots or roots. If roots are found, they are displayed neatly. If no roots are found, a warning is shown. Any runtime errors in a method are caught and shown to the user. Finally, a button lets the user return to the input screen and try again. This is the main control structure that displays the right page depending on where the user is in the session flow. And that wraps up the walkthrough of the RootFinder's app backends using Streamlit. It supports multiple numerical methods and guides users from input to interactive root visualization. Stay tuned for the next video where we'll build and explain each method UI.